Welcome. This question says a boulder has an angular momentum of 3 kg/m squared per second at time t equals 4 seconds. And net external torque causes its angular momentum to double in 5 seconds. What is the magnitude of this net external torque? So we have a boulder and it has a angular momentum, so L initial, if you like, is equal to 3 kg/m squared per second, and T initial is equal to 4 seconds. And then a net external torque, so there is a net external torque, but I don't know what it is, causes its angular momentum to double, so L final is equal to, well, it was 3, so now it's 6 kg/m squared per second. It causes it to double in 5 seconds. So T final is not 5 seconds. T final is actually going to be 4 plus 5 is 9 seconds. So notice you've got to be careful there. If it causes it to double by 5 seconds, that's very different from caused it to double in 5 seconds. So there's some interpretation there. And it's asking what is the net external torque. So I have to get some relationship which has torque and it has a changing momentum and a changing time. And I think it's not a particularly familiar one that we use, but you may recall that we said the sum of the forces equals ma. Oh yeah, remember that. But remember that Newton said the sum of the forces equals dp by dt? And that if we average things, we could say delta p by delta t. Well, based on that, we can have the sum of the torques is equal to I alpha, which equals dl by dt, which if we average things equals delta L by delta t. So then I can say, well, the sum of the torques is equals L final minus L initial over T final minus T initial, which equals, let's put some numbers in. L final is 6 minus L initial is 3 over T final is 9 minus T initial is 4. So the net external torque is equal to 3 over 5, which equals 0.6. And the units would be torque. So it's going to be Newton meter. So there we have it. This is not mathematically a hard question, it's just a little bit of multiplication. Probably the challenge with this question is the fact that it tends to be using equations that you may not have used very often. Everybody knows F equals ma. That gets, I guess, very little praise for being able to say F equals ma. But the sum of the forces equals dp by dt, that's less familiar to people. But if you can do that, then you can do the translation where you say, well, the sum of the torques equals dl by dt. And then it becomes much more transparent. So I don't think this is a hard question mathematically. It's an unfamiliar question. And so more time on task means it becomes more familiar. So there we have it.